Hi, my name is Wally Akbari, and I'm a storage specialist solution architect working at AWS. In my role, I help our customers on their journey to AWS Cloud. I'm excited to be able to host this session to help you on your journey in selecting AWS services to simplify your file storage architectures. When you think about it, data is generated or utilized in different aspects of your everyday life, from your morning coffee, to the car you drive, to the movies you watch, and the medicines you take. Data is everywhere and growing. This data could be in a structured format, like a database, or unstructured format, like file data. When you look at file data, there are many use cases. Think of all the photos you've taken with your phone over the years, or the documents you've created. How much more are you storing now versus a few years ago? And how often do you go back to clean up or archive data you don't need? File data is everywhere and growing, and users and organizations are continuing to accumulate more and more file data. Growing data volumes also introduce different complexities and challenges for customers, such as how can they operate as they grow without worrying about scale, performance, capacity, or reliability? Or how can they remain cost optimized? So the question is, with the ever-growing volume of file data, how can you simplify and optimize your file storage architectures so your business obtains the greatest value, and from your point of view, you spend less time doing the heavy lifting and instead focus on innovation? Let's look at some customer challenges associated with their growing volumes of file data. Firstly, customers tell us they don't want to manage the storage for file data anymore. They don't want to deal with its complexities, ongoing management overheads, capacity planning, and scaling challenges. Customers want to save money by avoiding upfront costs and any lock-in, and also want cost-optimized storage options. Customers want to easily process data faster and the capability to easily scale up performance. Security is important for us and also our customers. As the volume of data grows, customers want to ensure their data is secure and protected, such as through backups, without worrying about backup capacity, licenses, and management, and also secure access and the use of encryption. Customers want continued access and availability to their data and don't want to deal with the complexities in designing and maintaining high availability. Lastly, more data can mean more data silos. Customers want to simplify their architectures and centralize their data assets so they can unleash the power of their data through items such as machine learning and analytics. Looking at the AWS Storage Services portfolio, AWS provides the most complete cloud storage portfolio with the deepest functionality, unmatched security, reliability, cost, performance, and data protection. The AWS storage portfolio covers object, block, file storage, and backup and data transfer edge services. In this session, we are going to focus on 3 fully managed AWS file storage services: Amazon Elastic File System, Amazon FSx Windows File Server, and Amazon FSx for Lustre. I will then tie these 3 services into 3 user scenarios. I will firstly go through items that users generally require when they look at building their own file storage solutions. Then cover these AWS services to highlight the benefits of using the right tool for the right job and how they can help you build faster, simplify your file storage architectures, save on time and costs, and add value to your business. In this solution, we are going to look at 3 users and their scenarios requiring file storage solutions. Joe wants to accelerate analytic workloads and do more with his petabytes of data. Sophia wants to design a new app which uses traditional Linux servers, containers, and AWS Lambda. Ahmed wants to retire aging NAS and Windows file servers and doesn't want to spend time managing storage anymore. Joe, Sophia, and Ahmed could all take a build-your-own approach to build their own file storage solutions. There are a few elements they would need to take into consideration. Let's go through them. Firstly, file storage solutions usually require deploying a combination of software, compute, and storage nodes. This can get quite complex and costly depending on your configuration. Next, the users could invest weeks or months of time into researching, deploying, and validating a new file storage solution to ensure that it meets their current and future state requirements. This process can get even more complex when there is a need to design for high availability. Users want to ensure their file storage architecture is cost optimized and can seamlessly scale out for capacity and performance when their business needs it to avoid challenges in the future. Customers value their data assets. The users would need to protect their data using backups to a highly durable location. From a backup perspective, the users would need to figure out what backup software will I use, how much will the licenses and storage cost, can it scale for my future requirements, and importantly, who's going to support it? When the entire solution is built, then there's a question of who is going to manage and maintain the file storage solution they have built. That's a lot of work to do yourself, just to get a file storage solution up and running. Now, wouldn't it be great to avoid these complexities and time-bound activities with fully managed file systems that can scale in capacity and performance and are available to deploy in just minutes when your business needs it? Let's go through 3 user scenarios, and I'll introduce you to 3 fully managed AWS file services and their benefits along the way. Let's look into Joe's scenario. Joe is looking at ways his team can accelerate their data processing for their analytics workloads using their petabytes of data stored on Amazon S3. Amazon S3 is our highly available, highly durable object store, which customers can use for items such as the heart of their data lake, to application data storage, to backup and archive storage. Joe wants to be able to run some analytics workloads using a high-performance file system to accelerate their results. However, these tests only run for a few hours on a given day, where Joe and his team then spend a few weeks to review their findings, update models, and retest with new values. They will iterate through this cycle countless times, so they want a high-performance file system when they need it, but they don't want to pay for a high-performance file system that is continually running for the weeks when his team would not be using it. Ideally, Joe is looking for a solution he can spin up and spin down as needed, and can easily link to his data on Amazon S3. Joe and his team are not storage experts and don't want to deal with managing a high-performance file system or figuring out how to link it to their data in Amazon S3. Let's look at an option Joe has for this scenario. Joe could look into using Amazon FSx for Lustre, which is a fully managed AWS service that provides cost-effective, high-performance, scalable storage for compute workloads. Fully managed means we take care of regular security and maintenance updates. FSx for Lustre is simple to use. In just minutes, Joe can spin up a high-performance file system with a few clicks using the FSx console or through the API. Joe can then simply mount the file system on his Linux-based compute fleet nodes using the mount command, or use it with Amazon SageMaker as a file data source for machine learning. When Joe needs more capacity, he can increase the storage capacity of the existing FSx for Lustre file systems with a few clicks. We don't believe high-performance storage needs to have high cost. FSx for Lustre is cost-effective, where it comes in multiple deployment options, such as Scratch, persistent SSD, and persistent HDD FSx for Lustre file systems. This can help Joe optimize between high performance and cost. Lastly, Joe can spin up FSx for Lustre instances when he needs to use it to supercharge his workloads, and then spin them down when done to save further on costs. FSx for Lustre is based on open source Lustre, the world's most popular high-performance file system. These Lustre file systems are designed so that as you add additional storage capacity, you also add additional throughput capacity for performance. FSx for Lustre is designed for very high performance. It is able to scale up to hundreds of gigabytes per second of throughput and millions of IOPS while maintaining sub-millisecond latencies. It provides concurrent access from hundreds to thousands of compute cores to a single file system. Many high-performance workloads depend on countless compute instances accessing the same set of data through high-performance shared storage. That's where customers are using FSx for Lustre to supercharge their high-performance compute workloads, such as modeling and analytics in the financial services industry, to genome analysis in life sciences, and rendering in the media and entertainment industry. FSx for Lustre file systems can be created as a high-performance standalone file system, or also a system that is linked to an S3 bucket where your data resides, making data import-export operations really easy. Note, FSx Veloster standalone file systems are capable of having incremental native backups taken, which are durably stored on Amazon S3. These backups can be used to create new FSx Veloster file systems based on that point-in-time backup. Okay, let's look at Toyota Research Institute, or TRI, who are one of the many autonomous vehicle companies taking advantage of S3-linked FSx Veloster file systems. TRI is developing machine learning models for object detection. Training these models requires powerful GPUs supported by high-performance storage. In their case, TRI creates short-lived Scratch FSx Veloster file systems linked back to objects stored on S3. When it is time to train or update a model, TRI can spin up an FSx Veloster file system and seamlessly retrieve data from S3. When the workload is complete, they can just as easily spin down their file systems along with their elastic compute resources to save on cost. When Joe deploys a new FSx Veloster file system and links it with his S3 bucket, the metadata for each of these objects is automatically created within the FSx Veloster file system. So these S3 objects will simply appear as files within the file system that Joe can have mounted on the compute instances. Upon first access of a file through the file system, the actual file is loaded into the FSx Veloster file system from S3. Subsequent access to the same file through the file system is delivered directly from the file system with sub-millisecond latency. If Joe's workload creates new files or modifies existing files on the FSx Veloster file system, Joe can export new and changed files back to his linked S3 bucket by using the FSx Veloster's data repository export task. How easy does that make data import and export operations for Joe? Now let's think at scale. When Joe has workloads that use hundreds of thousands of cores spanning multiple availability zones, how can FSx Veloster help in that scenario? One of the benefits of S3-linked FSx Veloster file systems is the ability to create file systems in different availability zones, all linked back to the same S3 bucket. By doing this, Joe can create a single source of truth using his S3 bucket and its data, and can give compute resources in each availability zone the ability to access the same set of data through high-performance FSx Veloster file systems. Let's recap to understand how Amazon FSx Veloster can help Joe. Joe can use FSx Veloster instead of building his own solution to save on time and experiment faster. It is a fully managed AWS service geared towards high-performance compute-based workloads. Joe can use FSx Veloster to accelerate his analytics workloads when they need to be run. Then spin down the high-performance file system when he's done, and spin up again when needed to save further on costs. Joe can save a lot of time and decrease complexity in his architecture, as he doesn't have to worry about scripting any data import or export operations, as FSx Veloster can link with his S3 bucket. Now, best of all, Joe doesn't need to be a storage expert to deploy FSx Veloster. He can do this with a few clicks through the FSx console or use the API. Let's look into Sophia's scenario. Sophia is designing a new application stack that uses traditional Linux clients. Sophia is also looking to modernize aspects of the application stack using new container-based microservices. In the near future, Sophia is also interested in using AWS Lambda to create serverless functions in the application stack. Sophia needs a design pattern for a highly available, performant, scalable, and shared application file share that can easily integrate with Linux clients, containers, and AWS Lambda. Sophia is not a storage admin. She doesn't want to deal with designing or managing file storage and its complexities or how to back it up. Sophia wants something that's super easy to use, elastic in nature, where it can automatically scale up or down as you add or remove data. Let's look at options Sophia has for this scenario. Sophia could look into using Amazon Elastic File System, which I will abbreviate as Amazon EFS. Amazon EFS is a fully managed cloud-native NFS service designed for Linux-based workloads and supports client access from traditional Linux servers to containers and also AWS Lambda. It provides the capabilities in integrations Sophia needs to confidently run business-critical apps needing shared file storage in the cloud. Amazon EFS is simple to use, where Sophia can get up and running in just minutes and have petabyte scale elastic storage. It is elastic, automatically scaling up or down as files are added or removed, where you only pay for what you use. Now, how awesome is that? Performance automatically scales with capacity to petabytes in size, where Amazon EFS file systems provide low, consistent latencies in the single-digit millisecond range and can scale to tens of gigabytes per second of throughput and support over 500,000 IOPS. Amazon EFS is highly available, where all files and directories are redundantly stored within and across multiple availability zones. It can support concurrent access from thousands of connections from clients within AWS and also from on-premises clients via AWS Direct Connect and AWS VPN connections. Amazon EFS provides cost-optimized options such as standard and an infrequent access storage class to help Sophia achieve an optimal price and performance blend for her workloads. Best of all, Amazon EFS is serverless and scalable. Sophia doesn't need to provision any infrastructure or capacity. As the workload scales up, so does the file system automatically, accommodating any additional storage or connection capacity that is needed. Sophia can create Amazon EFS file systems in as little as 2 clicks. Sophia can also use the Customize option that's available to select the specific configuration of items such as automatic data lifecycle management policies for cost savings, to specific performance modes, to encryption, and so forth. Amazon EFS is meant to serve the vast majority of file-based workloads, covering a wide spectrum of performance needs. From single-threaded, latency-sensitive workloads, such as developer productivity tools, to highly parallel, scale-out jobs requiring throughput, like big data and machine learning applications, and everything in between, such as home directories and application shares. Amazon EFS provides 2 storage classes which can provide Sophia with automatic cost optimization. With this native lifecycle management, files that are not used frequently will be automatically moved from the standard storage class to the low-cost infrequent access storage class, completely transparent to users and applications. Infrequent access storage costs 92% less than standard, so imagine the cost savings Sophia could achieve for infrequently accessed data. Note that pricing shown is based on the Sydney AWS region. Amazon EFS can meet Sophia where her application is today and tomorrow. It's super easy to lift and shift applications onto Amazon EFS with minimal disruption. For existing applications backed by network file storage today, such as Linux clients accessing NFS shares, Sophia can use Amazon EFS as it provides the same type of interface that the applications and users are accustomed to. When Sophia is ready to modernize the application stack and move towards building microservices using containers or using AWS Lambda for serverless aspects, Sophia doesn't need to worry about which file service she can use, because Amazon EFS is there to support the new workloads as a simple, fully managed, elastic, highly available shared file storage service. Let's look at T-Mobile. T-Mobile needed to modernize its IT infrastructure to support a company-wide customer experience improvement initiative, where their on-premises facilities required constant management and provisioning storage took weeks. T-Mobile decided to move some applications to a container-based environment and also needed persistent cloud-native storage for their workload. T-Mobile chose Amazon EFS for its ability to easily and quickly create elastic storage for NFS workloads required by legacy and container-based applications. It allowed the customer to deploy new, modern versions of its legacy applications based on microservices architectures. The outcome was that T-Mobile accelerated the go-to-market customer experience initiative by up to 15% with Amazon EFS. They increased flexibility in developing applications with on-demand storage needs, reduced complexities of managing file servers, and saved between 40 to 70% on storage costs. Let's recap to understand how Amazon EFS can help Sophia. Sophia can use Amazon EFS to experiment and build faster compared to building her own file storage solution, as it's a fully managed elastic AWS service geared towards a broad range of Linux-based workloads. Sophia can decrease complexity and simplify her file architectures using Amazon EFS, as it's a fully managed service, it's simple to deploy, where you can have an elastic file system available in a matter of minutes. It's easy to use, where the file system grows and shrinks automatically. It has built-in high availability. Amazon EFS also provides Sophia with automated cost optimizations using data lifecycle management policies. Sophia can also have her Amazon EFS file systems easily backed up using the AWS Backup Service. Sophia can use Amazon EFS to support her applications for now and tomorrow. And best of all, Sophia doesn't need to be a storage expert to use Amazon EFS. Let's look into Ahmad's scenario. Ahmad is working on a project where he needs to migrate countless Windows-based file shares stored on file storage arrays and Windows file servers which are aging and need to be retired. These shares include user shares, which don't need a huge level of performance, but the users are storing similar Office document types. So Ahmad is looking for a simple and cost-effective solution, which also has a data deduplication feature. There are also application shares, which have high performance and growing performance and capacity requirements. Ahmad is looking for a high-performance option and also wishes he could change the performance or increase the size of a file share online with a few clicks, and for it not to take weeks to order capacity, then have it installed and provisioned. Ahmad wants to avoid re-engineering and wants a solution that he can use as a drop-in replacement where it can work with his already configured Microsoft Active Directory users and groups. Ahmad spends hours every day on managing the file storage environment and on planning capacity activities and performance activities. He doesn't want to deal with managing hardware, software, licenses, backups, and capacity and scale issues anymore. Let's look at an option Ahmad has for this scenario. Ahmad could look into using Amazon FSx Windows File Server, which is a fully managed native Windows file storage service built on Windows Server. This means you get fully SMB compatible shared file storage. It's fully managed, where you don't need to worry about provisioning or managing the infrastructure because we manage it. We take care of patches, maintenance updates, and even have automated backups, which are stored on the highly durable Amazon S3. It's really easy to deploy and use. You simply deploy FSx Windows File Server file shares and point your users and apps to the new file shares. FSx Windows File Server makes deploying highly available file shares even easier, using its native multi-availability zone mode, which you can achieve with a click during deployment. If you don't need the high availability that multi-AZ can offer, you can deploy it in a single availability zone mode. FSx Windows File Server is cost optimized. It offers two storage options to meet your cost and performance requirements. We offer SSD storage, which offers very high IOPS and sub-millisecond latency storage, geared for applications that are sensitive to latency, such as high-performance applications or SQL Server deployments. And then there's the HDD storage option, which still offers single-digit latencies to disk and high-throughput performance, and is geared for workloads such as user home directories, team shares, media workloads, and applications that don't need sub-millisecond latency of SSD storage. FSx Windows File Server integrates with Microsoft Active Directory, so you can use your existing users and group access control lists to minimize any re-engineering effort. This really makes it very easy to point your applications or users to FSx Windows File Server file shares without making any changes to your workflows. FSx Windows File Server is designed for a wide spectrum of use cases, ranging from customers using it for home directories and user shares, to line of business applications, to SQL Server databases. Creating an FSx Windows File Server and having it automatically backed up is super easy and would only take Ahmad a few clicks in the FSx console, or he could use the API. When Ahmad is done, the file system is running in just minutes, where it is fully managed and ready to be accessed by users and apps who simply mount the file share. FSx Windows File Server also supports data deduplication, which Ahmad can use to further reduce costs associated with any duplicated data. Ahmad thinks of the Windows user shares and how much similar Office documents are stored on these shares, and the cost savings he could obtain from data deduplication. When Ahmed deploys an FSx Windows file server instance, he can select the baseline throughput for his file system, which determines the speed at which the file system can service the data. One thing to note is you also get burst throughput capability for short periods of time. If you look at the table, even if Ahmed selected 64 megabytes per second of baseline throughput, he could obtain up to 256 megabytes per second of burst throughput for short periods of time. This can provide Ahmed peace of mind for situations where users or applications suddenly require additional bursts of performance. Let's look at Epic, an FSx for Windows file server customer. Epic, who work in the e-discovery space, was tasked with reducing costs for their e-discovery platform, which relied on shared storage. As their cloud-based platform grew, it became challenging to manage file storage themselves, where their costs of storage were increasing. Using FSx for Windows File Server, Epic was able to replace several hundred terabytes of their self-managed Windows file shares, where Epic reduced its e-discovery platform AWS cloud storage costs by 30%, using FSx Windows File Server's deduplication feature. Epic no longer had to worry about managing file storage. FSx Windows File Server was a drop-in replacement and just worked. Let's recap to understand how Amazon FSx for Windows File Server can help Ahmed. Ahmed can save time and increase business agility by using FSx for Windows File Server instead of building his own file storage. FSx Windows File Server is a fully managed AWS service geared towards Windows workloads. Ahmed simply deploys and consumes a file share and doesn't have to spend time on provisioning and managing file storage and its backups. This can free up significant time for him. With a few clicks, Ahmed can change the performance or size of his file system to give his business greater agility. Ahmed can use FSx Windows File Server as a drop-in replacement for his aging Windows file servers, as it can integrate with his self-managed Microsoft Active Directory. He can use the SSD or HDD storage options to balance between performance and cost optimization for his different workload requirements, and use data deduplication to save further on cost. Lastly, Ahmed can simplify his file storage architectures that need high availability by simply selecting the multi-availability zone mode when deploying his FSx Windows File Server instance. You can get started with fully managed AWS file storage services using these resource links shown. Okay, that's a lot of information to take in. So let's summarize. In this session, you've learned that AWS has fully managed file storage services that can cater for your different use cases, where they can simplify your file storage architectures and allow you to experiment and build faster compared to building and managing your own file storage solutions. These AWS services provide customers with greater agility and enable you to spend less time on managing and maintaining storage and its backups, and allow you to focus more time on business value items and innovation. This brings us to the end of the session. I wanted to say thank you for viewing my session, and I hope that through this, you are now better able to select the AWS storage services that can help you simplify your file storage architectures. If you've enjoyed it, please fill out the survey form. You joined AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS training and certification for AWS storage services. We offer 35 free digital and on-demand courses on our storage products, including Getting Started with Amazon S3. For advanced learners, we offer the Architecting on AWS Classroom course that covers storage and other AWS products. You can go deeper with labs, white papers, and other technical resources by downloading the AWS Ramp-Up Guides. For more information, refer to the training links shown. And remember, happy building.